Hello there and welcome to How Beyond Numbers, where we learn maths the easy way. In this video, we are looking at dependent events still under the probability. When we talk of dependent events, what does it even mean? So we would understand what they are, be able to identify them, and then use the multiplication rule once again that we used for independent events in the previous video to solve forward questions related to it. So let's quickly go into it. So we have the definition displayed here. Two events are said to be what? Dependent, right? If the outcome of the first event affects the outcome of the second event. You see, so after performing one of the events, you realize that it is affecting the occurrence of the other events. Let's see this in real life. So this over here is just a display of circles, right? And let's say all these circles are in a basket, right? And I want to pick just one of them. You see, I want to pick just one of them. If I come here and then let me say I do pick just this one. Sorry about that. So I come and I pick one of them, right? After picking one, what do you see has happened? The number of what circles has reduced. You see, someone comes again and then picks another one. You see, now as the number of circles reduce, it also affects the sample space. That is our possible outcomes that we can pick from. That is the whole or the basic idea on dependent events. You performing one experiment affects the other one as well, right? So then we use the multiplication rule to solve for what these type of questions. So then the multiplication rule for dependent event says that what if the event A and then B are dependent, take note, we only use this if they are what dependent. So if they are dependent, then the probability of A and B is what probability of A times probability of B, given that A has already occurred. What does this mean? So this you see over here, P A, right? So it is the probability of B, given that what probability of given that A has already happened, right? I do believe you'd get to understand this more if we take some example and then solve. So let's quickly take some example and then solve so that I explain it on that. So looking at our first example here, it says what? A bag contains 5 red and then 3 balls, 3 green balls. 2 balls are drawn without replacement. This simply means if we pick a ball, we don't put it back. And what this does is it will always be changing or altering the total number of balls you have in the basket at each time. So the question is you have to find the probability that both are red. You have to find the probability that the 2 balls you are picking, they are both red. So our solution. Now, we first of all need to find the probability that our first ball is going to be red. You see? So the probability that the first one is going to be what? Red. And that one is very simple. We know there are only 5 red balls. You see? So 5 all over the total number of balls. That is 5 plus what? 3. And 5 plus 3 gives us an 8. So the probability that we'll pick our first red ball becomes what? 5 over 8. Now take note that after removing your first red ball, it simply means after we remove our first red ball, it means that we have picked one red, right? And it will be left just 4 red balls. 4 red balls. Why 4? Because we have already picked one. There were just 5 red balls and we have picked one. So there will be left now 4. And we still have 3 green balls. You see? So it simply means that we now have 7 in total. That becomes our new sample space, right? Okay. With this sample space, we have a new question. So the probability of picking our second red ball would then be what? This time around, we just have 4 of them. So 4 all over our new total, which is what? 7. You see? So this is what we say. This is the probability of picking a red ball when we have already picked a red ball, right? Okay. Or in other words, that is probability of what? Second red when you have picked a what? A first red. You see? Now, the question says you should find the probability that both are red. So all we need to do is to multiply this first red by this second red, right? So probability that both are red is then going to be equal to what? Our 5 over 8 times your 4 over 7. And if we multiply that, that gives us a 20 over 56. Upon simplification or further simplification, we have what? 5 over 14, right? Hence, the probability that both are red is what? A 5 over the 14. So all we needed to do was to what? Find the probability of both events. The first one being what? When we pick a red. And then the second one is when we want to pick a red, provided we have already picked a red. Let's look at another example here. But before we do, take note of why we said this one was an independent event. So, yeah, sorry, why we said this was a dependent, rather, a dependent event, right? So we said it was a dependent event because it is without replacement, right? Without replacement. If we were to replace after picking, then we wouldn't have said they depend, right? Okay, so let's look at this question over here. It says in a class of 20 students, 12 are what? Boys, and then 8 are girls. 2 students are chosen one after the other without replacement. This is our prompt to let us know what we are dealing with. So without replacement, and what is the probability that the first is a boy and the second is a girl? What is the probability that the first is a boy and then the second is a girl? Let's look at our solution. The solution. Now, we first of all, they said the first should be a boy, right? So you look for the probability of picking a boy first. And that is going to be the number of boys. We know the number of boys to be what? 12. So 12 all over the total number of students. We said there are 20 students. So that is 12 over 20. Right? Now, take note that after taking one boy, we no more have 12 boys, but we have what? 11 boys. So there are now 11 boys. And for the number of girls, it still remain 8 because we have not taken any girl, right? And this means that what? We have a total of 19 students. So we now want the probability of picking a girl after we have picked a what? A boy. And that is also going to be what? The number of girls, which was what? 8. So 8 from here, all over the total number of students this time around, which is 19. Right? So we now come back to the question. It says, what is the probability that the first is a boy and then the second is a girl? So the probability that we pick a boy and a girl is going to be what? At 12 over 20. That is from here. Then times are 8 all over what? 19. And that gives us a 96 over 380. Simplified as 24 all over what? 95. So that is the solution to our question. I do hope this video was helpful. I'll leave some exercises on our next slide so you try on your own. Okay, so here you go with some questions to try. There are just 3 of them. You can try to test your understanding. So in this video, we looked at how to work with dependent events. If there's anything you don't understand, you can just rewind and then take your time going through the examples. And you can as well visit our previous videos if you missed anything. See you on our next video. Stay safe.